Okay, now I'm recording. Now I share my screen. Okay, I think we're good. I hope. I really, really hope we're good. All right, so for about a week, I've had some problems I put on our website on XYZ because I told you, like the homework, the XYZ, it just hasn't implemented good problems for us to do. I don't know why. It doesn't stop us from doing good problems. It just changes the way we do them. And I want you to have access to good problems. And so I posted this thing, practice. I think it's actually a picture of a page from our textbook. Yes, it is. And there are any number of them. I think I said a comment about it. Pay special attention to number 201 and 209. Has anybody done this? Have you paid special attention to 201 or 209? Okay, so you got some work to do. These are going to be on the test. And here's your chance to work at it. And there's more, there's some good news here. Partial fracts is some examples from another textbook that I've used in the past. And it just gets you some more problems to do. And I think I picked out a few of those that I would especially like you to look at, number 3A, 5A, and so on. Now, because, you know, in XYZ, when you hit the enter key, boom, it turns green or red, right? You get immediate feedback. Well, you know, when you're doing the work yourself, there's no way to do it. But you can go here, and I've solved some of the problems. Number 206, 206 and 209 are from the first one called practice. And it's actually a completely worked out solution on my whiteboard, and it's just a photograph. It's not a video, so you have to kind of follow my arrows, and you can track through it and figure out what's going on there. Okay, and then, I didn't want to move that. Same way, solution, it's just another problem. It's one that I highlighted up here. Right, so I asked you to take a close look at it, and then I worked it out for you. My advice for you is pretend like those solutions are not there. Go find the problem and solve it, and then compare to what I've done. And the answers have to be the same up to a constant. We're finding antiderivatives. So, you know, maybe, I can't imagine how, but maybe you did it a different way, a little bit different way, and your constant's different. That's okay. Everything else has to be exactly the same, like there's no variability. Now, when logs get involved, there's lots and lots of ways to write the same thing, but you should be able to tell. And then notice the last one I did here from these, number 22, it's from the second group, partial fracts. So I picked out one of those problems. I wanted a case 3 problem, and that's what it is. And then let's go down a little ways. Here's my Zoom when I'm occasionally in my office. Anytime you can ask me to open up a Zoom window, and I'll do it. And there's my Zoom ID. Okay. When I was gone a couple of weeks ago, I gave you a number you can text me at. Right now, I don't know if you saw that number. I know that 2 or 3 of you saw it because they're the only people I get texts from on it. I can put it up here if you think you might use it. Maybe I'll put it in the same window as the Zoom ID to have that kind of administrative information available. In fact, I can do it right this minute. No, I can't. I don't have the number memorized. I need my phone. I didn't bring it. I know that's something that somebody your generation would never, ever say in a million years. Didn't bring your phone. But, you know, an old guy like me, I didn't bring my phone. Okay, where are we? So that's Friday's class. And then we have there's like 40 practice problems. And, you know, you can come to my office, work the problem. Yeah, maybe you're not exactly like me. I'll work a problem, an antiderivative, and, you know, they're complicated. I'll admit it. I like to solve it. I like to challenge. But sometimes when I get done, I'm like, that's so weird, that can't possibly be right. So I'll take the derivative. And then, you know, on one of the problems I posted, I actually found a mistake on my work because I couldn't get the function back when I took the derivative. And so I went through and I found, and for whatever stupid reason, I wrote a 3 on this step and it turned into a 2 on the next step. And of course, it made my answer wrong, but I took the derivative. I didn't go ask my professor, like, I'm going to take the derivative. If I've done the work right, I'm going to get the function back. Okay. So you can always do that. You can check your work anytime you want. I encourage you strongly to work in pairs or triples. Find you a quiet room somewhere with a whiteboard and work together. All right. 3, this is the homework that's due tonight at midnight. I extended the date because some people asked me to, and I'm a nice guy. 219 is a class. So you guys all know, maybe, I know some of you know, we've not been able to meet in Lemons ever since the storm because the power's out. And so this is the 3rd class in a row, I think, that I'm recording this and posting it for people in the morning class. And some of them are joining us, Will and Matthew and Braden. And maybe that's it. Julian. Oh, I don't even know the answer to that. No one told me. It's on Zoom. I mean, it's always available on Zoom. If you need to know the Zoom ID, let me know. I think they're fixing. I thought PGE over in Lemon, so hopefully on this is Wednesday. On Friday, we'll be good to go. All right. So here's when I first started supplementing the XYZ homework. I posted this, and this has been a few, more than a week. So, and I renamed it. This file, when I first posted it, was just like practice. Well, that didn't really tell me anything. So I renamed it Trig Subs. So what do you think you're going to practice if you open that document? Yeah, absolutely. And I talked about on, come on. Oh, it opens in a new window, I think. Nope, that's not it. I thought I saw movement way over here. That's not it. That's not it. Let me try it again. I saw movement somewhere. This is a PDF.
It's downloading. So the little blue arrow pointing down up in the top right corner of the window.
Top right corner.
Yep. Back a bit.
There.
Yep. And then click on the first.
Oh yeah. It doesn't open in its own window. I did this 3 times in my office and I had 3 of them. That browser there, it just loaded them across the bottom. I don't know, is it going to show up? So there are 3 problems in there, not pictures from the book. They're problems I made up myself. Okay, and I talked on, I don't know, Monday or Friday, that if your professor makes up work for you to do, what did I tell you to do? Pay careful attention. Like, they're like my own little babies. Oh, there it is. It's beautiful on my screen. Okay, so I can go get it for you. If I can only find my browser or mouse. Okay, for whatever reason, it's opening up on the other screen. So here it is. Those are the 3 I made up all by myself. Okay, so take a close look at them. And not only that, Noah. Okay. Okay, so let's take a look here. You asking a question, Braden, or scratching your head? Okay. So look what I did. How many problems were in that PDF? 3. And what's right below it? 3 solutions. There again. Now, Noah, maybe you need to read through the first one. I mean, if you're shaky, but don't just go and read the solutions. Go and try to solve the problems. And maybe you'll just breeze through. Or, you know, but if you have trouble, or if you want to check your work, then you have solutions here. I think these are photographs, so maybe they'll show up. Yeah, so there it is on my board. I worked it all out, you can see, and so on. All 3 of them solved. And then we're back to previous classes. Noah, one of these is a video over trig substitution. I don't know which one, maybe 212B. The fact that it says B maybe thinks there's another one as well. It's going to be a video. It is, like I can watch me teach. Yeah, there it is, case 1. Okay.
Okay, picking up where the audio cut
Said
out.
okay,
of
right.
the First video I posted.
In real life and on video within like 2
We
seconds
are
of-
looking at
Shut up,
chapter 3, section 3.
rude guy. 212B. Now here's an assignment. Oh, look at that. I made it due tonight also. Somebody asked me. I mean, there was some confusion. One of the problems got assigned in June. Like, how did that happen? Don't answer that question. And so somebody didn't do it real fast. And then I changed it to when I really wish I would have assigned it to be due, and he missed the deadline. So he said, can you extend it? And I said, absolutely. If you want to do calculus, I want to create a way for you to do it and, you know, get credit. You can always do calculus and so on. And maybe most of these things we've gotten to. Trig integrals, this is 3.2. That's from section 3.2. So that's easy to keep track of. Here's some more. That's actually the assignment and so on. Any questions about information available? Now, most of this is available in the calendar, which is way down because I've added so much stuff. So today is Wednesday, and you can see those 2 assignments. I changed the due date to tonight because somebody asked me to. And they're red, I think, because like today's the day. Got to get them in. And on Monday, class, C stands for class, February 22nd, part 1. That's the video from the main part of class. What's practice? More practice problems. I don't know. And you can back up a few weeks and there's all the detail. All right, so now you know what's there. And I think I told you last semester I had a student who just clicked on, the first thing he did was click on calendar. And when I would post stuff that it didn't seem, you know, like maybe the right thing to do is put on the calendar, he missed it every single time. So I want you to scroll through and just look at things. If you have any suggestions for how I can organize it so that you can better tell like which things do you really need to look at. There are videos from class, there are assessments, and there are practice problems. The assessments always says do. All right. Any questions? Have you learned anything about the information available to you? Yeah. And again, if you have any suggestions, I know you guys don't like to talk to me. I'm not sure why, but if you have any suggestions, let me know any way that you can. Come to my office. You probably walk by it 5 times a day, every day, right at the corner of Clagis, between Clagis and the library. You have a Zoom ID. Maybe I've made it available all semester. Maybe you just found out today that it's available. And I also put a number you can text me at. It's in one of the early videos when I was out of town for a week. And I don't have it memorized, but I'll put it in that XYZ document. Any questions? All right. Still recording. We'll move into actually doing some calculus. Stop the share. Still there, Daniel?
Yep.
That was a test. If you passed.
Here.
All right. So Daniel, you let me know if I like write off the screen and you can't see what I'm talking about. Are there any questions on the homework? Yeah. Noah.
I have the integral of 4x over
4x over,
X squared plus 4x minus 12. I felt pretty confident in my answer and checked. the calculator as well. X, Y, Z.
all right, well, let's investigate. So, this is a rational function, perfect for our current technique. We need to factor the denominator, which looks to me like x plus 6, x minus 2. That look right to you? So we're going to decompose. Plus 6, x minus 2. We're going to write as some number. This is a case 1 problem. 2 linear factors that are not the same will equate numerators. I always do the same steps. Construct, first of all, factor the denominator, and then set up our decomposition pattern. And then 3, we equate numerators. Plus b times x plus 6. Because we're case 1, we can just plug in a well-chosen value. And what's a good value, Noah?
2.
2, an outstanding value. On the left, I get 8. On the right, I get 8b. So what's b? Okay, everybody with me? You agree with my equation? 8 equals 8b. All right, and then what do we do? -6. On the left, we get -24. On the right, we get -8a, and therefore a is 3. So our original antiderivative, we now know we can write as the antiderivative of a, 3, divided by x plus 6, plus b, 1, over x minus 2. So we get 3 ln x plus 6 plus ln x minus 2. Julian. Absolutely. It doesn't make one bit of difference.
I like more on one of the problems. I think I have my stuff. So, I'm not sure.
Yeah, so you can write in the decomposition in any order you want, because we learned early on that addition is commutative. Their terms, we're adding them up. But that means your A, it might be different from Ken's A, and it might be different from Noah's A. It just depends on the. Noah.
I just, I messed, I switched the x minus 2 and x plus 6.
So are you asking the same question you did? So are you telling me you had your 3 with ln x minus 2?
Yeah.
I believe this is correct.
I think I know what they did, because I kept making the same mistake, because I would start to read it as what you have down here in the equating of the numerators, a times a minus 2. And I put that 3 in front of that. So
Ooh.
I would like process it differently.
Yeah,
Accidentally do that.
So after we calculate the constants, this is where we go. Maybe you're on this. So we get the right constant with the right term for the antiderivative. Any other questions? All right. So, section, is it 4? Partial fractions. It's all about rational functions, right? It's a technique for integrating rational functions. And it only works if our rational function is what? Proper. Yeah, one of the examples I gave you that I worked out in the solution, it's improper. So I pointed out in my solution, and then, you know, what do we do if it's improper? We long divide, absolutely. And that's all worked out on the video. In fact, it's one of the ones that I said, pay special attention to these two. I think it was 201 and 209. They're both improper. And I think they're the only improper ones from that page that I posted. That's why I chose them. All right. Now, it turns out that we can run into rational functions as an attempt to find an antiderivative for a function we don't otherwise know. But as we'll see one, we don't know what to do. We've never seen anything like it before. We'll guess, sort of, that a certain substitution might work, and then we'll investigate if it worked or not, and we'll discover, if we do it right, that we're going to come up with a rational function. Okay, so then that takes us right back to section 4. Like, is it proper? Is it improper? If it's improper, long divide. And if we need to, I think the ones I'm going to do are not totally true. If we need to, then we can use our technique, our 3 cases, right? Depending on the factor denominator. So here's one of them. So I'll call this like surprising, because it doesn't look like it to start with. Rational functions. When I posted the solutions, like I told you, like I showed you, I took a photograph. And you know, some of them, there are a lot of details to work through. And my whiteboard's not all that big in my office. And so some of the steps that we've done together in class and we've talked through that, you know, maybe you're thinking, man, he could have put some more information in there, but I tried to take advantage of the space that I had and rely on you to remember like what we did with these to figure out, you know, how to follow the sequence. So also, as you saw, I drew some arrows to kind of help you see the flow. All right, here's one. 1 over e to the x plus 1 dx. That is not a rational function. Rational functions do not have exponential functions in them. It's a polynomial divided by a polynomial. Okay, so we're not surprised yet. You're surprised, like, why are you talking about this? That's not a rational function. But we don't really have any clue what the antiderivative is. I don't, just looking at it. I've never seen a function. I've never even come close to seeing a function whose derivative is 1 over e to the x plus 1. So, you know, what do we do? Well, I'm going to hope that a substitution will help us out. So I don't know. I mean, it seems like a shot in the dark to me, except that I've already worked through it and I know it's going to work. But if I were seeing it for the first time, I would think, yeah, that's not going to help us out any at all, but let's try it. We'll make a substitution. As soon as we do, we calculate the differential. Now we'll rewrite it in terms of u. So I get 1 over u plus 1. And then I have my dx. Well, if I divide by e to the x, I can figure out what my dx looks like. Those will cancel. And then this dx, I don't like the x in there, but I can write e to the x as u. So dx is du over u. Let's write it like this. And then let's write it like this. See how that works? So maybe at first it seemed like it didn't really have a chance substituting for e to the x, but in the end, I think it turned out okay. What kind of a function is that now in u?
The rational function.
It's a rational function. Surprisingly. Is it proper?
Yes.
Yes, it is. Degree 0 on the top, degree 2. So now we do our 3 steps. We've already done the first one, the denominator, it came factor for us. Now our decomposition, this is a case 1. I may be getting off of the screen. One over u times u plus 1. We're going to decompose into a over u plus b over u plus 1. We're going to equate numerators. We're going to plug in a well-chosen value of u. Anybody have a good idea?
-1.
-1. Excellent. 1 equals negative b. Therefore, b is, yeah, this is 0 minus b. And then what should we plug in?
0.
0. Get 1 on the left. Get a. Get the self-solving equation. Equals 1. So then we can spread our answer out. So the mistake we made on the last problem, we go back and we focus on our decomposition, not the equating numerators. I get the value of a, which is 1. Let me write this here. Over a is over u. And then we get b, which is -1, over u plus 1. And those are both logs. Case 1 is always all logs. Finish it over here. The only thing left is to replace the u. Remember, it's e to the x. So here, oh, interesting. It's the log of e to the x minus the log of e to the x plus 1. It's never negative, so I don't need absolute value signs. And then look what we can do. What's ln of e to the x?
It's just x.
It's just x. Here's our final answer. We'll add a constant to the final answer. Okay. Got any chemistry or biochemistry majors in here? So it's like the U is like a catalyst. If you've done the chemistry, like I think a catalyst is added to an experiment to kind of speed it up, but it doesn't really change it. Just kind of use. That's what we did with the U. It just kind of we brought it in. It converted. Amazing, surprisingly, it converted this to a rational function. We did our work, and then then we throw it away, and we say, well, let's go back to this. And there's our beautiful answer. Questions? All right, I have another one. Are we understanding? Good. Here's another one. Let's do kind of a gnarly one. The square root of x. If you really sort of decide you want to do it, finding antiderivatives, it can be as fun as playing video games. It's a good challenge. You have to really think creatively. You have to have some basic tools, but then you think creatively. And so here we go. Now, what I'm going to do, that is not a rational function. You can't have square roots or cube roots in a rational function. So we've never seen one like it before. I'm going to tell you what I'm going to do, and then we'll just see like if it works. I want to replace x with another variable, u, to a power so that all the fractional powers are gone. Right? The square root is a 1/2 power, and the cube root is a 1/3 power. So I want to turn all of those fractions into integers, and I can do it if I pick the power 6. 2 times 3, that's how I got it. a 1/2. You'll see how it works. And, you know, this is maybe the first time you've ever seen anything like this. And so it's not really your job to figure out why this is going to work. Just to trust me. But then if it works, then maybe your job will be to figure out the next one. Can we do something similar? As soon as we substitute, we compute the differential. Notice this substitution is like trig substitution. That is, most of the time, our substitution variable, we set it equal to a function. And that's what we learned in calculus. But then we got the trig substitution where we said we're going to replace x with this new expression, right? It's a different way of going about it. And this is the same way. We're going to replace x. And why do we do that? Because what's x to the 1/2? Well, it's u to the 6th to the 1/2. And what's that? U cubed. And what's x to the 1/3?
U squared.
Yeah, you see, it eliminates the fractional powers. Okay, so what do we get? We just showed the square root of x is u cubed. And the cube root is u squared. The differential is 6 u to the 5th. U. Let's kind of clean that up a little bit. Eighth, 1 over u squared. What kind of a function?
It's improper.
And, yeah, you're one step ahead of me, Will. What kind of a function? A
Irrational.
rational function, a polynomial divided by a polynomial. What do you notice about it, Will?
It's improper.
It's improper. We have a degree 8 in the numerator. So what do? We long divide. So u to the 6th, u to the 8th plus u to the 6th. It's going to take a few steps. Minus u to the 4th. Plus u to the 4th plus u squared. U to the 4th plus u squared minus u squared minus 1. Just ran out of room. So I got my minus u squared, then we're going to multiply and get minus u squared minus 1 more, subtract. So the remainders in blue have to go until the remainder is a polynomial of degree less than 2. You can see we had to go all the way down to 1. Dividing by u squared, we could knock the power down by 2 every time we divided. Eventually getting it down to 0. So what we have is this integral right here. I can write as the polynomial, the antiderivative of the polynomial u to the 6th minus u to the 4th plus u squared minus 1. And then we have a remainder of 1 over u squared plus 1. Everybody follow? Or you got questions in your eyes? Right here?
No.
Oh,
Is that the same as your one that's your?
this one? No, that's how many times u squared goes into minus u squared. So we got this remainder. We took out u squared out of u to the fourth, and that gets us u to the fourth plus u squared. We subtract and get minus u squared, minus u squared goes into minus u squared minus 1 time. Okay, any other questions? And now we have an obvious antiderivative, don't we? Just a polynomial. And then what's at the end? The antiderivative. Pardon?
It's a natural law. We know it's an arctangent.
It's an arctangent. Can we integrate and resubstitute at the same time? What's the antiderivative? U to the sixth. 1/7 u to the seventh, and u is the sixth root of x. Right? Since u to the sixth is x, u is the sixth root of x. So we get 1/7 x to the 7/6 for the first term. Is that right? Take a minute, make sure it's right. U is the sixth root, it's x to the 1/6, and then we raise that to the 7. That makes 7/6. Then similarly, as soon as you're comfortable with that, all the rest follow. X to the 5/6, 1/3, x to the 3/6, otherwise known as 1/2, minus u, which is x to the 1/6. Right? For this one, the variable is u, so the antiderivative minus u, and u is x to the 1/6. And finally, the inverse tangent of the sixth root of x, x to the 1/6, which is u. Are there any questions? Well,
So, should it be? I'm confused about the arctangent part. So if we're substituting what x to the 1/6 in for putting that in the arctangent, I was wondering if that would if that would work, because usually when we substitute things, we have to multiply by a derivative.
yeah, but we have already found the antiderivative. We've
Um,
already done it. So it's just substituting back in.
Okay.
Victoria.
For the u to the sixth, would be incorrect, I guess, since u to the sixth equals x to just. Is that whole thing, or do you have to? solve?
Well, okay, so u to the sixth is x, and then the derivative, antiderivative would be 1/2 x squared. Is that the right answer? No, your substitution, in relation to Will's question, is before we integrate. And so I think we need to be careful. Matthew,
For the rectangle,
Yep.
the unit of that arctangent. So we didn't see that. Can you do the fractional, partial, fractional,
okay, good question. So Matthew is anticipating a time where he needs to know this antiderivative, but he can't remember it. And so he goes, oh, it's a rational function. There's an irreducible quadratic. So I can take the function and decompose it, AU plus B, right? A linear, right? And guess what you'll figure out? If you solve it, you get A equals 0 and B equals 1. It'll just take you right back where we were. Good question. Maybe while you're doing that, then you'll say, oh, wait a minute. There must be another way to get it, and then you'll remember. Oh, yeah, the inverse tangent. Now, Will said, he corrected it quickly, but first said this is gonna be a log. And you see, if we had a U in the numerator, then it would be a log. Can you see that? Because the derivative of the bottom, to get a log here, I need the derivative of the bottom to be present in the top. And I can get any constant I want, but I can't move variables through the sign. So without a U here, and the derivative is 2U. The 2 is no problem whatsoever. I kind of deal with that all the time. The U is a serious, it's a fatal flaw for trying to make it into a log. It's impossible to do. Okay, so very, very common mistake. In fact, I've seen this mistake, like 1 over x squared dx is the log of x squared. Like people just sort of get lazy, I think. Whatever shows up in the bottom, it's the log of that. Well, no. This is actually a power function, the -2, so raise the power by 1. Like, you have to look at the function and say, what is the right rule for us to use it? Any other questions? Yeah,
So basically, anytime there's a higher power than 1, the denominator can't be a log.
okay. I wouldn't like to think of it that way. The question is, whatever is in the denominator, can we get its derivative in the numerator? And when I say, can we get it? All we can really do is juggle constants. I mean, I could break it apart into, can I legally, algebraically, get the derivative of the bottom in the top? If I can, it's a log. If I can't, it's something else. Okay? Any other questions?
Ready to move on to the next,
The next section?
yeah. The next surprising rational function.
Oh, well, maybe we're done with doing surprising ones in class. I'll put some on the homework, and I have a sneaking suspicion that they may not be embedded in the online homework, so maybe I'll get a chance to make up another of my very own. In which case, as a student, you put like a red star around that, like, oh, he made this up all by himself. He must really like this problem. Or maybe I'll just take a photograph from our book or some other book. On Friday, we will start the next section, which it's called improper. Well, it's not the next section. It's the next one we're going to do. It's a couple of sections ahead. It's called improper integration. And, it may be easy to think we're experts at that already, but it's like improper rational function. It doesn't mean wrong. It means something different about it. And we'll recognize what about it is different and how we're going to deal with it. All right. See you Friday.
Yeah.
See you, Daniel.
Yeah.